Voyager 1, NASA's farthest voyaging rocket, continues its amazing venture through space, flawlessly communicating significant information from the deepest areas of the universe. For almost 50 years, this phenomenal space test has revolutionized our understanding of space. However, as of late, the space apparatus has been communicating disturbing information back to Earth, leaving the entire space industry in shock. Are these troubling signals the result of a technical breakdown or the activities of extraterrestrials? Join us as we uncover the reality behind these stunning transmissions. Since the beginning of recorded history, researchers have been enthralled by the secrets that lie beyond our heavenly boundaries. This interest prompted the historic launch of the Explorer 1 and Explorer 2 shuttles, among other wonderful space missions. These momentous missions, which had been discussed for quite some time, began with the launch of Explorer 2 from NASA's Kennedy Space Center on August 21, 1977. 14 days later, on September 5 of that very year, Explorer 1 followed suit. These twin tests, each weighing a significant 720 kilograms comparable to a small vehicle, were propelled into space during a unique alignment of the outer planets. Throughout their staggering odyssey, these courageous voyages navigated different directions and speeds, leading to a crucial moment on December 15, 1977, when Explorer 1 outpaced its identical twin due to variations in their paths. Since then, Explorer 1 has become a significant asset, providing us with a wealth of information and unraveling space-related secrets. Before we delve into Explorer 1's startling new discovery that stunned the entire space industry, let's explore the exceptional images captured by the rocket during its pivotal Jovian imaging mission in 1978. Explorer 1 was positioned roughly 265 million kilometers from Earth. From this vantage point, it communicated a stunning number of photos back to Earth. In January 1979, it embarked on an exceptional 100-hour endeavor, capturing a mesmerizing time-lapse film exhibiting 10 rotations of Jupiter. A cornucopia of 3,750 pictures allowed us to observe Jupiter's magnificent dance in vivid detail. In the ensuing months, Explorer 1 wandered through the Jovian moon system, making a striking revelation: the presence of a small ring surrounding Jupiter and 2 new moons, which further expanded our understanding of Jupiter's fascinating domain. To ensure safe passage and prevent a potential impact with Titan, one of Saturn's moons, corrective maneuvers were executed. Explorer 1 continued its celestial journey around Saturn, revealing 4 additional moons: Mimas, Enceladus, Tethys, Dione, and Rhea. With the culmination of the Saturn mission, researchers decided to conclude the Explorer planetary mission, pushing both Explorer 1 and Explorer 2 beyond the bounds of our planetary group, leaping through space at an astonishing rate of 325 million kilometers each year. In January 1990, another chapter began: the Explorer interstellar mission. During this stage, Explorer 1 delivered some of the most famous photos in history, immortalizing the Sun and the majority of the planets. One person who played a vital role in extending the missions beyond their initial objectives was the prominent astronomer Dr. Vasil Sands. As a part of the Explorer mission's imaging team, Dr. Sands ardently advocated for capturing one final set of pictures as a goodbye gift to humanity. Against all odds, his steadfast determination bore fruit on February 14, 1990, when Explorer 1, positioned 6 billion kilometers from the Sun, embarked on a visual excursion well known as the Planetary Group Family Picture. These stunning images, totaling 60, added to the shuttle's remarkable collection of 670 photos. During its encounter with Neptune, Voyager 2 achieved an extraordinary accomplishment by recording wind speeds exceeding 13,100 meters per second, making it the fastest wind ever documented within our local planetary group. As the rocket ventured within 280 miles of Neptune's blue methane atmosphere, It provided us with remarkable insights into this distant celestial body. Notably, Neptune's largest moon, Triton, was revealed as one of the coldest residents within our planetary group, with surface temperatures plunging to a frigid -391 degrees Fahrenheit. Triton's peculiar features, such as its nitrogen gas-spewing ice volcanoes that pushed icy particles 5 miles into its nebulous atmosphere, also captivated our imagination. These exceptional discoveries expanded our comprehension of the vast variety and complexity of celestial objects residing in the farthest reaches of our local planetary group. Don't go anywhere. The Explorer 1 rocket has recently made one of its most frightening discoveries. But first, let's find out what it has achieved in the last 45 years. The accomplishments of the Explorer twin tests have been nothing short of extraordinary. More than 4 decades ago, their initial observations of Jupiter and Saturn's moons left scientists in awe and shattered previous assumptions about these remote worlds. These moons, once believed to be dead and heavily scarred like our own moon, turned out to be teeming with geological activity. Explorer 2, in particular, achieved several exceptional feats during its journey. It made history in 1986 by becoming the first shuttle to fly by Uranus. Just 3 years later, it achieved another remarkable feat with a flyby of Neptune. Up to the present day, it remains the sole rocket to have ventured on such a path. As the Explorer rockets continued their journey, NASA implemented various measures to extend their operational lifespan. Over recent years, unnecessary parts and heaters have been deactivated to conserve energy, ensuring that these courageous explorers can continue their mission well into the next decade. Their estimated mission end date is set for 2030. For the scientists and engineers who have been involved in this remarkable project from the very beginning, the culmination of the Explorer missions is both a moment of pride and a tinge of melancholy. Their steadfast dedication and passionate efforts have far surpassed their initial expectations. The wealth of data returned by the explorers has provided valuable insights, fueled numerous scientific discoveries, and ignited the imagination of countless researchers and space enthusiasts. Explorer 1 and Explorer 2 were no ordinary space probes. They were meticulously designed as stable platforms with a rotation rate over 15 times slower than the hour hand of a clock. This design decision minimized visual blurring as the spacecraft captured images and data while journeying through the infinity of space. Even before their encounters with the outer planets, their impressive imaging abilities began to astonish scientists and the public alike. The spacecraft began transmitting images of Jupiter before reaching the gas giant. These early images, displaying the swirling clouds and iconic Great Red Spot, delighted audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly took the spotlight. Io, somewhat larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The spacecraft's instruments identified peculiar signals from Io, which were confirmed by the distinctive images they captured. Towering volcanic plumes and a surface scarred by volcanic eruptions were revealed. One of Io's most prominent volcanoes has erupted with a force 10 times greater than Mount St. Helens, covering an area almost the size of France. While the spacecraft's cameras were ultimately shut down to conserve power and memory before their journey into interstellar space, it is noteworthy that the photographs they captured did not include Mercury and Mars for various reasons. Aside from the Explorer 1 and Explorer 2 interstellar probes, NASA has also operated other prominent spacecraft like Voyager 10, Voyager 11, and New Horizons. Explorer 1 passed by Voyager 10 on February 17, 1998, marking the occasion when Voyager 10 became the most distant spacecraft. Explorer 1 continued its solitary journey for an additional 14 years before finally entering the interstellar environment on August 25, 2012. Although there were no other space probes in sight to witness, NASA didn't publicly announce this remarkable achievement until 2013. What procedures ensured the success of the Explorer missions? One method stood out as particularly brilliant: gravity assist maneuvers. These maneuvers played an essential role in propelling Explorer 1 and Explorer 2 on their audacious mission to explore the outer reaches of our solar system. To reach these distant destinations and gather valuable data, the spacecraft needed more than just their own propulsion systems. They needed a boost, and gravity assists provided just that. Imagine the two fearless rockets, Voyager 1 and Voyager 2, embarking on their grand tour through the local planetary group. Instead of relying solely on their motors, they engaged in a celestial dance with some of our local planets. Heavyweight planets formed groups that performed an incredible dance, leveraging the vast gravitational pull of these giants to slingshot themselves on their way. This method allowed them to conserve valuable fuel and gain the necessary speed to visit various destinations. Delving into the fundamentals of gravity assist, also known as a gravitational slingshot, we see that the idea behind this maneuver is to transfer some of a planet's energy to the spacecraft as it passes by. Imagine Explorer 1 approaching Jupiter, a massive gas giant with a matching gravitational pull. With meticulous precision, Explorer 1 swung by Jupiter at the perfect angle and speed. Jupiter's gravity tugged at the spacecraft, accelerating it to a higher velocity and providing it with a significant boost. Performing a gravity assist maneuver requires exceptional precision. If Explorer 1 had approached Jupiter at the wrong angle or speed, the slingshot might have resulted in a disastrous deviation from its intended course. However, the brilliant minds behind these missions successfully executed these gravity assists multiple times, propelling the Explorer spacecraft on an astonishing journey through the local planetary group. Explorer 2, for example, utilized gravity assist from Jupiter and Saturn to reach Uranus and Neptune. These celestial maneuvers were of vital importance in making the grand tour possible. The Explorer missions owe much of their success to these gravity assist maneuvers. Explorer 1 continued to reach interstellar space, with Explorer 2 quickly following suit. All thanks to the accuracy of these maneuvers. The concept behind gravity assist is simple, but the execution is extremely complex. Explorer 2's grand tour required a level of precision where missing any of these slingshots could have resulted in a failed mission. However, the dedicated individuals behind these missions were determined and steadfast in their pursuit of knowledge. While gravity assists played a significant role in exploring the universe, another critical component ensured the success of the Explorer missions. The Deep Space Network, DSN, often considered the interstellar phone line that kept us